Hello everyone, we are Group 12 and today we're going to present our data science final project. From gathering the data set to data cleansing, exploratory analysis, data modeling, and evaluation. I am Rich de la Vega and I will be discussing the data gathering part of this project. In this phase of our project, our main objective is to dive into the music and mental health dataset. This dataset likely contains the information about what music individuals listen to, and how they rate their own mental health. Our goal here is isn't just to skim through the data, is to dig deep and uncover meaningful connections. We're on the lookout of significant correlations and patterns that show us how someone's choice of music might be linked to how they perceive their mental well-being.
Hi, I'm MAIA FELIZA ATIGA and I'll be explaining our data cleansing. In this phase, we want to identify the relationship between the user's music taste and their self-reported mental health. And we will determining whether the dataset contains any null values or a values that we need to disregard. So, can you go up the first code? So, in this code, we disregard three categories that seem to be redundant, which is the permissions, timestamp, and primary streaming services, because it doesn't align with the objective of the survey, which is the relationship between the user's music taste and their mental health. Now, in the second code, we have our cleanse dataset that we remove the redundant categories.
Hi, my name is Crystal JC Narvaez and I'll be explaining EDA. This dataset offers a comprehensive view of music listening habits and preferences, along with insight into how music intersects with mental health among respondents. And further analysis can reveal patterns and correlations between music preferences, listening habits, and mental health indicators. The general problem is that the goal is to explore how aspects of music listening, genres, frequency, and context relate to mental health outcomes, seeking patterns indicating associations with better or worse conditions. Data science questions. At the end of the analysis, I would like to find the answers to the following questions. 1. What streaming service do people use most frequently? 2. What is the age distribution of the respondents? And 3, do people listen to music while working, studying, and relaxing? In the first part, what is the age distribution of the respondents? After conducting a careful examination of the categorical information, we continue to look at the variables that contribute to individuals included within the tuning into music. 2. Do people listen to music while working? We collected data from the dataset, which incorporate the natural impacts to listening to music. This investigation will give intensive data about the members. And 3, we have here the favorite genre versus anxiety. And then 4, we also have the favorite genre versus depression. And lastly, we have favorite genre versus insomnia. And the very last, we have favorite genre versus OCD.
I am Joshua Lawrence Calsado and I will discussing the data modeling. Our goal in the data modeling is to forecast the mental health results of individuals by analyzing their music tastes. Utilizing machine learning methods, we seek to identify important relationships and patterns in the dataset that links music with mental health. This predictive approach aims to improve the efficiency of music therapy practices, and offer meaningful understanding into the complex relationship between music and mental health. The code is counting the occurrences of each unique value in the music effects column. The counts indicate how many times each value appears in the column. This information is useful for understanding the distribution of different music effects in the music effects column of data frame. The next code is procedure for creating a logistic regression model to predict categorical outcomes using a dataset. Prepare the data. The dataset is divided into features X and the target variable Y, which is music effects. Data preprocessing. Numerical columns are converted to numeric types which errors handled gracefully. Categorical columns are hot encoded to transform them into a machine-readable format. Standardized features. Features are standardized to have a mean of 0 and standard deviation of 1, ensuring equal weightage in the model. Train the model. A logistic regression model is trained on the standardized training data. Make predictions. The trained model is used to predict the music effect on the test data. This workflow encompasses data preparation, model training, and prediction, following standard practices in supervised machine learning for classification tasks.
For the data evaluation, I am YURIC MAMALES, and here's the explanation for our data evaluation part. So we use two powerful machine learning models called logistic regression and random forest to understand the relationship between individuals' favorite music genres and their reported mental health indicators. This model is adept at predicting three classes: improve, no effect, and worsen. Here's the breakdown of our precision, recall, and F1 score for each class. For improve, our model achieved a precision of 79%, indicating that when it predicted movement, it was correct 79% of the time. The recall, or the ability to capture all instances of improvement, was 74%. For no effect, precision and recall were lower at 31% and 38% respectively. Interestingly, our model struggled to predict instances of worsen with precision and recall both at 0%. Overall accuracy for the logistic regression model and 64%, suggesting room for improvement. For our random forest classification report, moving on, which excels at handling complex relationships within the data. The precision for predicting improve was 75%, and recall was a high 97%, resulting in a solid F1 score of 85%. However, the model faced challenges in predicting no effect and worsen, both resulting in precision and recall of 0%. The accuracy for the random forest model was slightly higher at 73%, driven by its success in predicting improve. For our confusion matrices, let's visualize how our models performed with confusion matrices. In the logical regression confusion matrix, you can see correct predictions, diagonal, and areas where the model struggled, particularly in predicting worsen. The random forest confusion matrix showcases strong performance in predicting improve, but struggles with the minority classes. These insights will guide us in refining our models and exploring ways to enhance predictive capabilities, especially for less common outcomes. Both models performed well in predicting the improved class with high precision, recall, and F1 score. The no effect and worsen classes pose challenges, especially for the random forest model, where it struggles to predict instances in these classes. The overall accuracy of the random forest model is higher, but this is primarily driven by its ability to predict the majority class improve, and the F1 score provides a balanced measure of precision and recall, considering both false positives and false negatives. And that is our final project in data science. Thank you.